Okay guys, Assalamualaikum and good day. Welcome back to chapter 4, friction. We'll continue on the video number 2. So mainly we are doing some exercise to further understand on the topics of friction, earlier friction. So we have a crate over here, positioned at a slanting plane. It's a 20-degree slanting plane. Crate is 180 Newton with a coefficient of static friction between crate and plane is a 0.4. And then what we have here is this is a motor or gearbox is pulling the crate at a horizontal direction to the right hand side within 90 Newton. So the rope have a tension of 90 Newton to the right hand side. So the question is if the rope exert a 90 Newton forces on the crate to the right hand side, so what is the friction force exert on the crate by the ram? So the question is asking for this frictional force acting by the crate on the crate by the ram. So we are putting axis over here. Like say this is x axis, this is y axis, because we are dealing with a contact plane over here with a slanting contact plane 20 degree. So we are having x and y axis over here. This is the normal force acting perpendicular to the contact surfaces. This is the subcomponent of weight of the 180 cos 20 Newton, and this is 180 sin 20 Newton. What else we have here is a subcomponent of the tension of the rod at x-axis is 90 cos 20 Newton, whereas on the y-axis is 90 sin 20 Newton. So as we know that total force acting on the contact surfaces on the x-axis is equal to 0 because the crate is still not moved. So the total force at x-axis is equal to 90 cos 20 subcomponent of the rope at x-axis minus 180 sin 20 on the crate itself minus FR. We are taking right hand side is a positive because we are expecting the motor and the gearbox is pulling the box to the right hand side. So that's why we are taking the right hand side as a positive. So this is negative. This one friction force also negative. So the answer we get the frictional force acting to the left hand side is 23.01 Newton. The second question is asking for what is the largest force the rope can exert on the crate without causing it to slide up the ramp. What is the maximum tension of the rope that we can apply to make sure that the boxes is just want to start move to the right hand side, or the maximum tension of the rope acting through the crate to ensure that the boxes is just want to slide up the ramp. Okay, this is the normal force. This is same apply the subcomponent of weight 180 cos 20 180 sin 20, but the difference is T max, because we are looking for what is the maximum tension allowable for the rope. So we just put T max cos 20, and then this one is T max sin 20. So of course by the time this is the maximum tension applied, and FR also is the maximum because it's just nice because the crate is just nice it's just begin to slack up the RAM. Okay, this is basically the free body diagram that you have to be familiar with. Okay, just plug in all the data into the equation of the total force acting on the x-axis is equal to Tmax, because we are taking right hand side is positive. So Tmax cos 20 minus 180 sin 20 minus Fr max is equal to 0, because the crate is still not moving. So by the time it's still not moving in equilibrium mode, so the equation is equal to 0. The next one is, we know that Fr max is equal to mu n. So we know that this one is Fr is a frictional force. Frictional force is equal to mu n. So from the y direction, from the forces acting at y direction, so maximum force is actually 0.4 the mu times normal force. Normal force, this one is actually 180 cos 20 plus Tmax sin 20. Same applied to the y direction. So the total force acting at y direction is equal to 0. So normal force acting positive direction of y-axis is equal to 180 cos 20 plus Tmax sin 20. So this is the equation. So rearranging the equation, you get this is equation number 1, this is equation number 2, and then you just put equation number 2 to equation number 1. Simplify the equation, you get this equation until you get this simplified equation. So you get Tmax is actually 160.9 Newton. So you have to do it again by yourself, recalculate back, and then to further understand the step ahead. So thank you very much.